didn't check out the hint online if you did number 1 the long way. Whoops. Bummer if you were here after school and I didn't remember there was a shorter way. But actually, to be honest, to be totally honest, you were supposed to solve number 1 the long way, and then you were supposed to get to number 27 and be like, oh my goodness, it could have been simpler. That was technically the design of the homework assignment originally, but I posted that comment, that hint in there earlier, so I went over it yesterday for those people that were here for number 1. But really quickly, in homework, when were you unable? Ooh, and we have a nice AP FRQ to play with in just a little bit. Why in number 1, whether or not you used my hint? Why in number 1, whether or not you used my hint, did you need to at least somehow do this a longer way? Why couldn't you just go to endeavor number 26? And why couldn't you just use those shortcut rules? Why in number 1 did you have to use a longer way? Okay, it is centered at 0, so it is technically a Maclaurin, but it doesn't match one of those special ones or the derivative or the integral of one of those special ones, right? So therefore, we have to go back to the definition of, okay, f of 0, f prime of 0, f double prime of 0, fill it into the formula with f double prime being over 2 factorial, etc. Why, oh, come on, you can do it. Why does number, oops, that's not the one I want. Yeah, 13. Why does number 13 also fail us being able to strictly use endeavor number 26? It's not around 0. So those are the 2 times. The 2 times when you can't use a special Maclaurin is when it's not around 0, it's around something else. You have to go back to the definition of a Taylor polynomial. They're saying Taylor series. We're just saying if you're only writing so many terms, it's technically called a polynomial, not a series. The series would be the infinite series. Or I guess when we refer to Taylor and Maclaurin series, we're talking about the infinite series. The Taylor and Maclaurin polynomial, we're talking about the finite, the approximate, the only so many terms. So I just wanted to let you guys know, or make sure that you did realize, in number 1, yep, no shortcut for that in the sense of no endeavor 26. And down here, number 13, also no endeavor number 26 because it's not centered at 0 anymore. Guys, you were able to access the answers last night, yeah? Okay. I'm pulling them up just because I am ready to go over questions if you guys have them fairly quickly. However, before we go over them fairly quickly, let's see where you're at right now. Ready, set, back of your homework spirals, go. You, yourself, and you, we're going to take 10 minutes. But FRQs are 15. Yeah, but I'm not entirely sure. We're ready to face all 4 of the parts. Let's do 10. And traffic lights take off a little bit of the strain on your eyes, even though I guess in some ways it's a little bit more. Back of your homework spiral. This doesn't say it was the 6th FRQ on the BC 2008 exam. It said it's similar to, but it is quite similar to. So if you want to put down, if you want to go reference the scoring guideline or the grader's notes or sample student solutions, this is like the 6th question on the 2008 BC. Yes, Melanie Patos is selling candy bars. You guys did put her on your sweatshirt, so you could support. Anyway, but $1 each is definitely fun. If you guys have any money for sweatshirts, now is a great time to come back. Quarter 6, so 30 weeks. And it's going to be in a smaller box, the one on the right. The exciting discovery of today was that the quarter zips have the nice fuzzy inside too. wasn't sure they would. I was excited they did. Medium quarters like that. Of those who have been working, who's still on part A? Still on part B? Still on part C? Still on part D? Okay. I was just seeing where everybody is. But just to help you, have you guys seen the function as a geoseries with an a sub 1 of 1 and an r of x squared? That might help. Just in case you got stuck at the beginning. You've seen it as a geoseries with an a sub 1 of 1 and an r of x squared. Alright, pause, start talking it out. I think you've at least been able to get done what you could quickly. Or at least been able to think through it. Collaborate. What's good? What's bad? What did you know right away? What did you not?
It's too big to get zero.
Until I said it was a geoseries. How do you make geoseries? A sub 1 over 1 minus 2. Which means, instead of having to take the derivatives, I can say, oh wait, I just start at 1. And then I multiply by x squared. Yeah, 1 minus negative x squared. Now, how do you make a series out of that?
Okay. We're supposed to do first term
10.1.
10.1.
Remember this guy?
Yeah.
So, what's my a sub 1? Times, what's my radius? Or my ratio? See it?
You don't like oh, yeah.
Yeah, it says in the general term.
That's
The question was asked, it's a calculator question, and the answer is no. Dean and Gavin, they're talking it out. I'm going to go ahead and start playing with it up here on the board.
Huh? Because of the negative.
Oh,
yeah.
the negative.
Well, I got there. Good. And then, oh, yes, you got also every time. Oh, yeah, you said negative 1.
I start at 0 because I'm thinking of f of 0, like the 0th derivative first, second, third.
0, 1. That's 0.
If you didn't mention it,
Just plug in 0.
Did you guys catch that in part A? It didn't say polynomial, it said series, so it wasn't supposed to stop, it was supposed to keep going. Letter B. Does the series converge? Does the series converge? Hold on, convergence. What do I know about convergence? I have a geoseries, right? With a common ratio of negative x squared, right? I don't have an interval of convergence where my absolute value of r, which is the absolute value of negative x squared, needs to be less than 1. Joe, what's up?
Y is at the top. Why isn't it? Is it the first term 1? So wouldn't it be negative x squared to the n minus 1?
Oh, I was having my series start at n equals 0.
Oh.
Because I was thinking of this being f single prime, double prime, triple prime. It's going to be easier for me in stating it if I'm using 0 because it starts at the 0th term. But you could. Ooh. With Taylor and Maclaurin, I think we should always start at 0. With Taylor and Maclaurin, it's almost always 0. Now that we know the Taylor and Maclaurin polynomial formula of f of and then f prime of. Yeah, let's start at 0. But good thought, if you're starting at 1, you probably had a correct representation.
You have to say, like, starting at 0 and starting at 1.
For Taylor and Maclaurin's, we pretty much always start at 0. unless they state otherwise, just because of the way that the formula is set out. And I think we even have that, in that darn debit card. We'll double check the formula. As far as the nth term of the Taylor-Maclaurin polynomial, I think the n is based on starting at 0, because the 0 is derivative. We just haven't really thought about it until right now, I don't think. So, sorry, convergence. Oh, hey, so when we do the convergence, don't we know that x needs to be in between? So what's bad about evaluating at 1? It's not inside the interval of convergence. So what am I going to say? I can say since x equals 1 is not, you can say it's not within, you can say it's outside the interval of convergence for the series. And why don't we just say no, right? No. The series. I didn't want to have to keep going. Nope, it's not going to work. Why? It's outside the interval of convergence. Okay, we're done. And we stated geoseries. I mean, we should state where we got the interval of convergence from, but yeah, geoseries, and we're good. Okay, part C. Whoop. Now what? The derivative? What? Oh, wait a minute. They actually gave me all the information I need because they said the derivative of who or what? Arctan. The derivative of arctan is 1 over 1 plus x squared, the original guy that we started with, right? Okay, so now what? Write the first 4 non-zero terms of the Taylor series. They just told me this is the derivative of the guy that you want the Taylor series for. So can't I go ahead and think arctan now of x is going to, we haven't talked about this yet. Yeah. It's whether I do equals or whether I do approximate. I'm doing a Taylor series. I'm just going to put a colon, just to be safe. Right, the first 4 non-zero terms of the Taylor series doesn't say anything about justification or explanation, so we can just go for it. We have our first 4 terms, right? Boom, 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 boom. What are we going to do to go from a derivative backwards? Integrate. So therefore, my first term is going to be and it just said write the first 4 non-zero terms. Oh, did I go the wrong way? Oh, goodness. Thank you. I did good after that, though, yeah. Thanks. Wow. It's one of those days. If this guy is the derivative, which he is, 1 over 1 plus u squared, or 1 over 1 plus x squared, if he's the derivative of arctangent, sweet. How do I go from a derivative back? I integrate. How do I do it with a Taylor series? I integrate term by term. Yes. I integrate term by term. I don't think we would be wrong if we just show the dot, 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 and that's just us indicating the Taylor series. We don't have to do the general term, although we could have pretty easily. We could have done n plus 1 over n plus 1, just like the power rule for integration. But what's going on in part D now? I'll read it because it's gotten small, right? Use the series found in C boop, to find a rational number A such that, I want to find this guy. Now, hold on, what does this kind of look like? The estimation, alternating series estimation theorem, right? Sorry, estimation remainder theorem. There we go. But what was in that original endeavor card? Isn't this an a sub n plus 1 given an actual s and an s sub n? Right? Who's who? This is the actual. Oh, that's what the actual is. This is our estimation. That's what we're approximating with. And this is our error. Well, this is our error bound. It's bound by 1/100. So, So we're trying to figure out how many terms. Ooh. So we're trying to figure out how many terms we need to have the error be within 1/100, and then we're going to actually take that part of the Taylor polynomial and plug in 3/4. So how do we figure out how many n's we're supposed to have? Until we know how many n's, we don't know how many pieces to take from our Taylor polynomial there. Our alternating series. Okay, so how do we find n? How do we find n? Make a general formula. Okay, so we could go ahead and solve. This is a non-calculator question. This is a non-calculator question. I mean, we could. What would our general term be? Learn to say, make a general term with an n and solve for n. But on the test, didn't you guys get up against one with a factorial where you couldn't actually solve and you had to kind of play with it anyway? So you have two routes. I'm just trying to show you two routes. One route is to make an expression, set it equal to, and be like, must solve for variable. The other one says, plug in stuff and see how high we go. So if we're going the must plug in for variable route, okay. Didn't I just say that there was a way to make an a sub n expression by saying, let's take the old a sub n expression and let's say, you know what, you need to get raised to the n plus 1 all over n plus 1. Boop. Then how do we go one after that? Oops, n plus 2. And we need to set that less than 1 over 100. Yay, go solve for n. Now wait a minute, hold on. I have two variables. That's my first dilemma. I have two variables. I have x and n. Do I know one of those? Are you sure? I know x. Because check it, doesn't this tell me what to set x equal to? So technically I could go ahead and throw this in and be like, wait, for this specific example, it's not just that I'm trying to get it less than 100. I'm trying to get it when plugging in 3/4. Wait, I'm going to do absolute value of this whole thing anyway, right? Okay, so let's not worry about that negative anymore. That's kind of silly. Okay, so I know that 3/4 squared is 9/16. I know that 3/4 squared is 9/16. But what do I do with that n plus 2 up in the power? Oh, I can make it to the n and then times and squared. I guess I could do that. Does anybody realize that without a calculator, this is going to be gross? Kind of like that factorial one on the test that I ended up making bonus that you guys need to get back. Sorry. It's been great. I've been only working on updating gradebook and Google Classroom. What if we tried plugging and chugging? What would that look like? So Lorenzo, not a bad idea if it was easy to do. But I think instead what I would do is I would just start plugging in and saying, hey, 3/4, what is that as a decimal? Is 0.75 less than 100? No, I need it to be like 0.01, right? Okay, then keep going. What's the next term going to be? So I have 1/3 of 3/4 cubed. Hold on, that's going to be 27 over 64. Wait, but 27 and 3 is going to reduce 9 over 64. So 9/54. How's that one looking? Compared to 1 over 100. It's too big, right? So let's keep going. What if I was to do 1/5 times 3/4 to the 5th? Now what? I have 3 and 3. Sorry, 9 and 9 is 81, and one more is 243. Once again, if you don't believe me, this is question 6. Question 6 is a non-calculator question. Only questions 1 and 2 were calculated, right? maybe 1 and 2 and 3. Okay. So we have 243 all over. 4 and 4 is 16. 64, 256, 512. Do you guys know the powers of 4 are like good computer numbers that you should know? Oh, I'm going by 2s instead of by 4s? I'm going by 2s. Yeah. My bad. I was going by 2s. We have 4, 16, 64, 256. Thank you. And 256 goes to 1024. You could know these numbers a little bit better if things were in megabytes anymore, but now they're in like gigatera, whatever. How's this one looking? Good, kinda? How'd you get 1 over 125? What are you looking at?
242 over 1024 is like 1/5 times 1/5 is over 125.
Okay, so Kevin's seeing if you kind of look at the 243 and the 1024, kind of rounding a little bit. If you're thinking 1/5-ish and then 5 and 5, 1/25-ish, it's a lot closer than it was a second ago. But what's the problem? 1/25-ish is still bigger than this guy. But what's going to be, if worse comes to worse, if you don't want to do a lot of number crunching, what's going to be your hope and your guess when you do the next one? Now here's the question that you should be asking. Go ahead, throw it in your calculator. Let's see how we're doing. But as you're throwing it in your calculator, does the AP actually need you to do all of this number crunching to go ahead and throw in a fraction and to show that that fraction is 0.00 something less than that? No. No. They don't. All they need you to do is something like, hey, hopefully you guess right. I mean, hopefully you figure it out right.
How does 1 over 135 bigger than 1 over 100?
It's 1 over 25.
Oh.
Oh, you were thinking 125. I think it was over, right? Because it's 1/5-ish. Yeah, so 1/25-ish. Yeah. Now, for some of you guys, didn't we just figure out that this was 243? So I know that that's a very imprecise way of doing it. Over 1024, yes, times 1/5, but now it's times 1/7. And now we also have an additional 3 squared and 4 squared, so we could multiply. You don't have to rework the wheel and start all over again. You don't have to rework it and start all over again. So you could go ahead and go here. And then remember, we had 1/5-ish, and then that's 1/2-ish. So that'd be 1/10-ish. And then we have 1/70th-ish. Wait a minute, is that looking good yet? Do you guys plug and chug it? Does it get below 0.01? But it's not 1 over 25 because that 5 changes to be a 7. See what I mean? Which is why I rewrote it. So I took this 1/5-ish, 1/2-ish, 1/7. So that's 1/14-ish. That's 1/70th-ish. It's not good enough yet, right? Did anybody actually get me the decimal? What is it? I have a whole lot of easy kids. Go ahead, Joe. What's up, Ben?
Would they ever have a question where it's like, so with this one you can like, if you wanted, you can just write 10 terms and then say that they'll love you. Maybe there's no, it doesn't say you can't go too far. It just says find a.
This one doesn't. There are others. Great question where it says find the smallest number n such that. Yeah, that's a great question. Because Joe's saying, well, why don't you just plug in 100 and be like, yeah, well, I don't want to write 100 terms, number one.
You can do 10.
But yeah, you could do 10 and have a pretty good guess that you should be good. But there are others. I think they've changed the wording a bit since 2008, and that the ones I've seen at least the last 5 years or so pretty much always are asking for the lowest. Or the first time when, or term when. Yeah, good question. So that one doesn't work, but I'm pretty sure if we go one more, which you might be like, wait a minute, what? Well, we could just change this to be a 1/9 instead of a 1/7, and now we have another 3 squared. So now we have a 1/2-ish and a 1/2-ish, which is a 1/4-ish, and then times a 1/9-ish is a 1/36-ish, times a 1/5-ish, that's going to be 1/150th-ish. Definitely less than 1/100. Now that was a lot of ishes, right? That's a lot of danger, except we're not looking, remember, the AP is not looking for us to actually prove this as a decimal. I've made sure, and this one, to be honest, the wording that Joe is asking for, it not being there is very much to our benefit, because we just need to find a place where we are for sure. And then, wait a minute, what are they actually asking for? Find a rational number A such that. So what would my rational, if this term is less than 1/100, then don't I, oh, wait a minute. Isn't it the sum of all the ones that came before because of the alternating estimation remainder theorem? Alternating series estimation remainder theorem. I can say, oh, sweet, since I just put 1/9. I don't have to be snazzy in my notation. Is less than 1/100. The 7th degree Taylor polynomial approximation. Since the 9th one is less than 1/100, go one back, and one back from that is the 7th degree Taylor polynomial. Or in my alternating series, it'd be the sum of the first, 4 terms? Which would be my 3/4. I'm just rewriting it because I started rewriting another argument down here. Plus 1/5. Do we have to actually find it? No. Why? Such a thing as stick it to the man. Is A. According to, what can I state? Yeah, the air turned down. Sorry, it is cold. If you're under a vent, you can try budging one way or the other. Okay. Was this an adventure? Yes. Was it impossible? No. Was the number crunching a bit messy? Yes. But here's what I need you to see. Did you need to solve this all the way out? No, we just had to approximate. And did you notice that every time we were multiplying by 3 squared over 4 squared, every time we were multiplying by 9/16? Now careful, it's not a geoseries, because this is 1/3, then 1/5, then 1/7. But it is similar in the sense of we can just change the 1/5 with a 1/7 times 9/16. Change the 1/7 with a 1/9 times 9/16. Is it 9/16 approximately 1/2? 9/18-ish? A little bit higher, but approximately. We just needed to make sure it was below that 1/100. And according to Joe, he's like, yeah, just throw in 10. Okay, well, you can make that, it would be less than 1/100, but be careful for when it shows up and says something like the smallest. Now, it wouldn't say the smallest A. I guess it could. Anything bigger would be adding, subtracting more. I don't know. It would usually say something like the least number N, or the least number of terms, or the smallest Taylor polynomial. Excuse me. And in that, they wanted you to find like the first time it happens. But anyway, that's a good FRQ for us to at least kind of refresh our memory on power series 10.1. Interval of convergence, still kind of 10.1. But also Taylor polynomials and how they could be used. This isn't geo anymore. It's arctan, and those little constants in front are changing, even though it's kind of similar to geo in some ways. So reminding us of how it could be used. But you guys had homework, and so you guys were already able to access the answer key. I'm just curious if there's any place we need to jump to as far as, what's going on? 26. 26. If you guys haven't yet checked your evens with the answer keys, you can open up Google Classroom. I have it off to the side here too, so if you want us to actually talk in detail about any of those solutions, we can refer to it. According to the answer key, I think it's this one. There we go. Because it says Maclaurin. Yeah. So we have 2 over 1 minus t squared, which looks a lot like a geoseries to me, yeah? Except this is a geoseries with an initial term of 2, right? Remember, a sub 1 over 1 minus r. A geoseries with an initial term of 2 and with a common ratio of t squared. So my part A, this is very similar to what you just did, right? So I can go ahead and, let's see, if I'm trying to do my Maclaurin, if I'm trying to find my Maclaurin, I can say, okay, I have my 2 plus, and it's a minus, which means my common ratio is what it is. There's no alternating sign. It's just a positive t squared. So 2t squared plus 2t to the 4th plus, how many terms? 1, 2, 3. 2t to the 6th plus, and the general term, 2. You guys just saw the AP FRQ ask for it also. And I have t squared raised to the n, because it's n minus 1. If I'm talking about 0, right? Because there's no t squared to begin with. I need it to be t to the 0 first. Then t to the 2, then t to the 4, then t to the 6. If I'm starting at 0. Oh wait, I'm starting at 0. Silly me. N's good enough. I was back in when we were starting at 1. That actually makes it a little bit easier because I can just say 2t to the 2n. Yeah, that's a little bit easier. Generated by the series? Whatever, series, dot, dot, dot. Letter B says, find the first 4 non-zero terms in the Maclaurin series for G. Ooh, for G? G is, what's the name of this guy again when they go from some sort of a to an x of a function? Accumulator. It's an accumulator function. G is accumulating for higher and higher values of x, the area under f, or the changes occurring as a result of f's rate occurring. But anyway, the accumulator function. So, how do I get to G by doing what to f? Integration. So then what's B going to do? Two-thirds x cubed plus 2/5 x to the 5th plus 2/7 x to the 7th. And it doesn't say general term. Now let's check it. Hold on. Let's see if it got rid of it all. Number 26. They did it this whole way of bring out the 2, make it look like 1 over 1 minus r, show the geoseries, then bring in the 2. I don't know. Could you guys have started at 2 and just said times t squared times t squared times t squared? And then, oh, it didn't even show B? Oh, sorry. Oh, that's just, I must have copied it off. That's the wrong one to show you. There you go. Yeah, just integrate term by term, and you can stop. It just says the first 4 non-zero terms. Oh, wait, and the Maclaurin series. Ooh. It doesn't say the general term. If it wanted the Maclaurin series, it might have been asking for the entire series. We haven't really done a lot of series questions yet. We did the polynomials mostly. Series, I just told you to add dot, dot, dot. I know, everybody was packing up. But I think, Lorenzo, what I would have done is I would have done 2 over n plus 1? No. 2n 0 plus 1. Yeah, and then we have x to the 2n plus 1. Yeah. Okay. Sorry, we'll do a quick recap of questions. You guys don't have, obviously, any new homework tonight. Unless you want to go looking at Taylor and Maclaurin FRQs tonight, that'd be fun. You can try to stump me with something tomorrow. Otherwise, we'll do quick homework questions before moving on to 10-3.
I was integrating the function, and I got out using the partial fraction, and then I got stuck.
Oh. Lorenzo, I see. Yeah, they weren't